All right, in our first example, we are going to just fill in a couple charts, work on some vocab, kind of discover some patterns of things. So let's get started. We've got our first polygon, which is a quadrilateral. Here's a picture of a quadrilateral. So what can we determine about it? How many sides does a quadrilateral have? It will have 4 sides every single time. That's how it gets its name. The number of diagonals from a single vertex. So what that means is if we pick a vertex, I'm going to pick this one, and I'm going to draw any diagonals to any other vertex that is not like, I could go to this vertex here, but see how that's already a side of the polygon. So I can draw to that vertex there, that's one diagonal, and that's the only one we can draw. So we can draw one diagonal. When we drew that one diagonal, we created triangles within the polygon. So how many triangles were formed by that diagonal that we drew in? Here's one triangle, here's 2 triangles. So we have 2 total triangles. Now what we're working toward is finding the sum of the interior angles. A quadrilateral has 4 interior angles, 1, 2, 3, 4. So the question is, what should all those angles add up to? Every quadrilateral's angles will add up to the same total sum, even if the individual angles are different between different quadrilaterals. What we can use to help us is the fact that there are triangles inside of a quadrilateral. We know that the sum of the angles inside a triangle is 180 degrees. So this angle plus this angle plus this angle is 180. Well, we have another triangle whose sum is 180 degrees, which is this angle plus this angle plus this angle, and that covers all of your angles in the quadrilateral. So the sum of the interior angles is those 2 triangles times the 180 degrees gives us a total of 360 degrees for the sum of the interior angles. All right, so this is going to start to go a little bit faster now that we've talked through what we're doing here. So a pentagon has 5 sides. If I pick a single vertex and draw in diagonals, I've got 1, 2 diagonals. How many triangles did that form? 1, 2, 3 triangles. And then the sum of the interior angles of the pentagon is the sum of the interior angles of the triangles. Well, there are 3 triangles, so 3 times 180 gives us a total of 540 degrees. If I were to take this angle, plus this angle, plus this, plus this, plus this, gets me to that 540. All right, a hexagon has 6 sides. Pick a vertex, draw in our diagonals. We have 1, 2, 3 diagonals we can draw in. That formed 4 triangles. So the sum of the interior angles in a hexagon is going to be 4 times 180, which gets us to 720 degrees. So are we noticing any patterns in our numbers yet? That's kind of what we're doing here, trying to discover things about these polygons. All right, a heptagon has 7 sides. Pick our vertex, draw in our diagonals. We've got 1, 2, 3, 4. And how many triangles did that form? 1, 2, 3, 4, 5 triangles. So the sum of the interior angles in a heptagon is 5 times 180, which gives us 900 degrees for the sum of those interior angles. All right, so some patterns we can start to talk about while we're working on these last 2. My octagon got cut off a little bit, so I'm just gonna use the patterns we've come up with so far, what we're noticing. An octagon has 8 sides, and so if we take a look at how many diagonals can you draw from one vertex, do you notice how it's always 3 diagonals less than the number of sides? Did you guys notice that yet? It went from 6, 3, 7, 4. So if I have 8 sides, that means I must have 5 diagonals. And then Another thing to notice is if we had 7 sides, we formed 5 triangles. When we had 6 sides, we had 4 triangles. So it's always 2 less than the number of sides. So if I have 8 sides, I'm going to have 6 triangles, and the sum of my interior angles is 6 times 180, which is 1080 degrees. All right, a dodecagon has 12 sides. I know that I can go down 3 and get my number of diagonals, 9. If I take my 12 and go down 2, I've got my number of triangles that would be formed. And so my sum of the interior angles is 10 times 180 degrees, which is 1800 degrees. Okay, we're going to finish this video. Well, nope, okay, we're going to fill this in, and then we have one other thing to fill in. So let's just make sure we've got our names of our polygons. Polygons are named based off of their sides. If a polygon has 3 sides, that is a triangle. And some of this we just saw on the chart above, so it's a little review, but that's okay. A 4-sided polygon is a quadrilateral. 5 sides is a pentagon. 6 sides is a hexagon. Those are G's. They look a little weird as I'm writing them. It's skipping over 7, but we had 7 in the chart above. 7 would be a heptagon. 8 sides is an octagon. 9 sides is a nonagon. 10 sides, decagon. Some of these make sense, you know, like decade, decagon. 12 sides, we had that one up above. That's a, oops, dodecagon. A 15-sided polygon is a pentadecagon. And in general, if you have n sides of your triangle, like if it gets to be so many sides, it doesn't get a special name, we call it an n-gon. All right, so polygons are named based off of their number of sides. And then here we have our polygon interior, oops. There we go. Trying to find my pen. Polygon interior angle sum theorem. So the sum of the measures of the interior angles of a convex n-gon. So it doesn't matter how many sides, you can always find it the same way. So this S with a subscript of I, that stands for the sum of the interior angles. So it's just a little abbreviation. And you can find the sum of your interior angles by taking 180. 180, those are those triangles we were using in our first chart. Multiply it by n minus 2. So we saw that your number of sides, if you subtract 2, that's how many triangles we were forming. We took each triangle times 180 degrees, and that's how we got the total sum of the interior angles. Here's what this looks like kind of written out in picture form. If we have this polygon, 1, 2, 3, 4, 5, 6, 7, a heptagon, then the angle measures, the interior angles will add up to equal 180 times n minus 2. Our n is 7 because there are 7 sides. 7 minus 2, we do the math, we get 900.